Let's come together. First of all, each time we have a class lecture discussion, I'm going to call it story time. This is the story of statistics. So we're going to look at it that way. I'm also right now recording it. So that's why I've got this little microphone. It will record it. Whatever's up on the screen will be recorded. You can see it later. If you happen to miss a day, you'll be able to see what exactly we did in class. Okay. And I know there's maybe one or two of you who were working on getting you access to Canvas. We'll get that, but the rest of you will have access to it. You don't need it while we're going through the story. So just your notes, the note sheet is really all you'll need today, okay? There's some information in here. Let's see what, and what I've got for us is chapter 1. So there we go. And so what you'll see is that we will start off with, I don't know why it likes to go in and out on me, but it does. Maybe. Okay. When I finish, this is where I'll put the recording. I'll put a link to that. It'll be on my YouTube channel that you can take a look at. We've got the notes, which you have in front of you, so, but I just put them there just in case. And then there's also, then when we're done, we'll go into the Pearson My Lab, probably doing that tomorrow, not today. And there are also some other resources I want to point out to you here as we go back and review things. See what's going on. So there's a summary, frequently asked questions. So there's some of the questions are asked here. So this is almost like a textbook, provides a lot of information. And again, statistics is going to be a lot about vocabulary. Here's some vocabulary defined for us. So those are all here too. So there's all these resources. What my goal is for you is to learn how to use the words. And when you see the words, you kind of know what it's talking about. Not that you can write a nice textbook definition of them, but that you could use them. Okay. So those are here. But today we're going to jump into the slide deck, which I actually already have open. And we're just going to discuss, and I'll try to keep on time here and move forward. We're going to be discussing statistics. And so we'll start off with what we say is our objectives. What are we supposed to be learning? What are statistics? Again, more formally than what we've talked about before. There's a couple words here that we're going to focus on definitions. We're going to be talking about populations and sample. How are they similar? How are they different? What do they mean? There's two other words, parameter and statistic. By the time you're done, we'll know the difference of those two. And finally, descriptive and inferential statistics. Maybe I shouldn't get too close to it or something. I don't know. It doesn't like me. Descriptive and inferential statistics. So we'll know the difference between those. And we'll look at examples because that's one of the best ways to see examples of what is and what isn't something. Okay. So first of all, what is data? We've talked a little bit about this, but it's information. It can be numbers, but we're going to see it could also doesn't necessarily have to be numbers, but about observations, things you go out and look at. You go out to the parking lot, say how many white cars are there, how many red cars, how many blue cars. That's data. Okay. There's counts, measurements, responses. So it's all data. And something like this, you can take surveys, and this on the arts. 7 out of 10 Americans believe that arts unify their communities. Okay, that's great. That's a piece of data. And here's another piece of data. 2 out of 5 Americans believe that arts has changed their life. They went and asked people, and now we've got some data about that. Americans for the Arts is where it comes from. Sometimes we see data listed as a percentage. So we've collected a lot of information, and then we say this percent has, in this case, 21% of 8 to 11-year-olds have a social media profile. So again, collecting data and then doing some calculations with them. So percentages, we'll be doing quite a bit of that. So what is statistics itself? There's actually two uses that we make of this word. One is the main use that we're looking at. It's a science or a field of study, and it's a way of analyzing this data, collecting the data, doing anything with data. That's statistics. However, you will also see this word used as the data itself, right? Someone might say, oh, you don't want to be a statistic. That means you don't want to be in that number of people who were in a car accident or something. You want, so we can also apply the word statistics when we're talking about the data itself. Okay. And we'll see it has a specific application that we're going to use as well. So here's the first division of things. When we're doing statistics, we generally deal with two groups. One group is the one we want to know information about, and that we call the population. And it will be all the people or all the things that we want to know about. However, if we wanted to know the opinion of every high schooler in the USA, how long would it take us to get that information, right? We'd have to go ask every high school student. It's a lot. So instead, with statistics, what we will typically do is we will work not with the population, but with the sample. We'll say, oh, this person looks good, so yeah, we'll include this lady, this guy. So we have sampled the population. We've taken a few, we'll ask those 3 people, and we'll say it applies to everybody else. What we're going to do with statistics works as long as that sample we took is representative, which means it's very similar to the population. There is a whole science to doing that. You can't just randomly necessarily get a group and say that, okay, these guys are representative. So we'll do that a little bit later. Actually, I think in 1.3, we start looking at how to sample in a way that is representative, that gets us there. But it's much easier to work with, much easier to ask 3 people instead of maybe in that case about 12 people. Okay, so sample. So different between a population and a sample. Population is what we really want to know about, but we get that at them through a sample. So here's an example. What in this is the population? What is the sample? And it's very easy to confuse it. So we had a recent survey. 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. So what is the population here and what is the sample? And it's easy. Anyone? What do you think? What's that? 834 is that all we want to know about, just these 834 people? They're just the part so this is where it's confusing. They gave us 2 numbers and you say, oh, the smaller one should be the sample, the larger one should be the population. But in this case, the 834 is actually the sample we selected from all the workers in the US. Okay, sometimes it's hard to see this. So the implied one is we want to know about all the employees in the United States. So that would be our population. The 834 are going to be our sample. Now, you could get real tricky and say, well, that's the population of the sample, right? So it's the ones that were chosen. But what we're typically, when we're studying something, it's the population is what are we interested in? Not just those 834, but we're interested in all the workers in America, and that happen to be the sample. Now the 517, those were ones that answered, right? So they're a part of the sample, and they're ones that answer in a specific way. So what you'll see is the population is responsible for all employees, Again, we didn't ask everybody, but we're trying to get at what they would have. The sample is the H34, and then there's a subset, 517 said yes. Now, they make the assumption that everybody else said no, but we weren't told that, were we? We just told 570 said yes. Have you ever taken a survey and not answered a question? Sure, I don't want to answer this one. So we don't know that necessarily. We could just subtract the 517 and everybody else said no. Some might not have answered, but maybe they had more information on that. So we'll take that. But again, you kind of see this, the populations, everybody, and then within that, we have a subset. We just take a sample. And again, we're going to see, as long as we do a good job at taking that sample, we could then say that's representative of what everybody else in the US is feeling. Okay. Now, 2 other words go with the numbers, the measurements we take. We're going to use the word parameter to be something, a numerical description from a population. So if you see the word parameter, because it has a P, it applies to which one? Population. Okay. And so there must be another word that we use for a measurement that comes from a sample. And the cool part is it also starts with an S, so sample is a statistic. So that's what I mean. When we're talking statistic as data, we're talking something from a sample, not from the population. If you went and asked everybody in the population, that all of a sudden is now a parameter. Okay. And usually the way statistics work is we get data that is statistics from a sample. We do our magic with it, we do our math, and then we're able to apply it to that population. But there's sort of an inference. It might be right, it might be wrong. But that's a whole thing of statistics. Okay. But whenever you see something that says we've got a statistic, what does it apply to? It applies to the sample. If it applied to the population, what would we call it? Parameter. Okay. And the pause is there because as you say it, you're using more part of it's becoming deeper into your mind and your brain, those pathways. Okay, so here's an example. Decide whether it's dealing with the population parameter or sample statistic. In the United States, a survey of about 9,400 individuals aged 15 and over found that such individuals spent an average of 5.19 hours per day. 5.19 hours per day in what were they doing? Leisure and sports activities. Is that a statistic or a parameter? And why? It's a statistic, why? It's a number, but in its decimals, but who does it apply to? It applies to the sample. They got it from the sample. Very good. Excellent. How could we make it a parameter? We would have to tie it to the population, right? We'd also found that, but right now it's just a statistic because it came from that sample. Okay, and yeah, based on the subset of the population is a sample statistic. Good. How about this one? The freshman class at a university has an average SAT math score of 514. Parameter Y. So it's all the freshman class. You got the textbook's answer. I gave a different answer. If I were going to do a different answer, if I said it was a statistic, what am I thinking to make it a statistic? That, well, the 5, it would apply to a sample. So I'm looking at the freshman class as a sample of the university, right? Because the university has freshmen, sophomore, right? It's not just all freshmen. That's how I read it. And there wasn't enough information to say, no, we're only interested in the freshman class. But the textbook says, yeah, it's a parameter because it's all from all freshmen. And that was their population. But they didn't give me that information. I think, I know, university freshmen are only a part of it. So again, what I want you to see is that we can answer things in more than one way. But the reason we're answering it is really what's important. And so you could say, I would discuss with this book, okay, yeah, okay, if it's only the freshmen, then you got to say that more clearly so that I know it's a parameter. If it's, including all in the university, then it's going to be a statistic. Okay, and a lot of times it depends on what the perspective of what we're doing. If I'm a counselor, a freshman counselor, maybe that's all I care about in the college, right? Just the freshman, because that's my job. Okay, now same type of thing. So we've got, in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Is that a parameter or a statistic? And some of these may be different than what's in your notes because I think they updated the PowerPoints. It's from the same textbook company, but so you might find similar things. Parameter, statistic. Statistic, why? Very good, exactly. That's the defining characteristic. Didn't do them all, it's a sample. It's got to be a statistic. Perfect. And I think they tell us, yeah, it's a subset of the population. They didn't go to all the stores, so it's a statistic. So you see, in statistics, the big part of this is how we read the English, and how they described it. And sometimes we miss, even little words can make a difference. And that's one of the frustrations I had, like when you get into probability, sometimes a change of a word makes a difference. So you really got to read carefully. Okay. There's two types of uses of statistics, of data. And remember, these are coming from samples. One is descriptive statistics, and that is just kind of collecting data to describe a population. How tall are they? How old are they? How this and that? Just kind of getting a description. And we can use various tables, and we will do this as one of our aspects of just describing things. Even things like the average, that's a description of a group. There's other use of the statistics is inferential. So we take that sample data and we're able to apply it back to the population. Okay, so we're inferring that what we collected was good enough data that represents the population. Again, we're going to, a little bit later, we'll look at how we sample, and if we do it correctly, we can make this statement that our sample is very much like the population. It's representative. There's 50% women in the population. There should be 50% women in our sample, right? And if it's different, so there should be representation in our samples. So we can do that. Okay, inferential and descriptive. So if it only applies to the sample, it's a descriptive statistic. Only if we can apply it to the population does it become inferential. So let's look at this example. Let's determine whether it's inferential or descriptive, and then what we could do. A study of 512 US adults found that 18% of the adults from a household earning less than $30,000 annually do not use the internet, as shown in this figure. Now yours, if you look on your notes, the numbers are different, but 18%, is that number, is it a descriptive statistic or is it inferential? Descriptive, because it's only dealing with the sample, right? It's based on those 1,502 people. How could we make it to be inferential? Who do we need to apply that number to make it inferential? The population, right? So we'd have to connect it somehow. And again, we'll learn how to do that later. It's mostly how we selected our sample. We could say our sample was representative, so then 18% of our population. Now it is the same number, but now it's inferential statistics. When it's only about the sample, it's just a description. Make sense? Okay. Here's another one we want to look at. And in this case, we also wanted to identify what's the population, what's the sample, because that will help us. And then we can talk about whether it's descriptive or inferential. So we did a study of 1,000 US 401k retirement plan participants. And we found that the percentage who do not know how many years their retirement savings might last is 32%. Okay. So what would be the population? What would be the sample? And I'll just tell you, I usually have an easier time finding the sample. What would be the sample? The 1,000 people. Yeah, that's who we asked, right? The study had this. So it's 1,000 US 401k retirement plan participants. So once we have the sample, we also know who the population is. The population is going to be what? Replace the word of 1,000 with all plan participants in the US. So the 1,000 is my sample. So I know I took my sample from a larger group. The larger group would be all retirement plan holders. Does that make sense? Okay. So now that we know the difference between our population and our sample, this value here, is this descriptive or inferential? Who does that, which group does that number apply to? It's descriptive. Why? It applies to the 1,000, the sample, right? How would we make it inferential? We say that, therefore, 32% of all plan holders because we took a good sample. Exactly. You got it. You got it. Perfect. That's by Charles Schwab. So, okay. So this is actually the end of 1.1. What we're doing is getting into 1.2 because these concepts go together well, and it will also allow us to basically spend one day kind of getting this information, and then we can work on the homework, which as you'll see is as you're getting this notes, we'll kind of work a little bit on those. It'll make doing the homework much easier. So what we're going to do now is there's two types of data, qualitative and quantitative. And notice the words are very similar, so it's hard to differentiate sometimes. So we'll talk how to do that. I think it's my battery I need to get updated or something. And then we're also going to look at, the last part is that there are 4 ways of they call them levels of measurement for data. So we're going to identify data into 4 different categories. Okay, so first, qualitative data. This is, think of it in terms of quality. So quality is what we're talking about. It has a characteristic. These are not numbers. These are just labels, names. Something like, what is your major? You don't say, I've got major number 4. You say, I'm an engineering major. I'm an art major. I'm a science major. I'm a history major. So it's a list. It's a name. Where were you born? You don't give a number. You give what city you were born in. I was born in Seattle, Washington. Anyone else from Seattle? No, no one from Seattle? Okay. That's okay. I didn't live there very long myself. Eye color. Eye color is not a number, right? The brown, black, blue, green, hazel. Yeah, so they're names, right? You can't do math with these things. You can't take blue eyes plus brown eyes, and you just can't do that. Okay, so non-numerical entries. The other type is quantitative, and I think of the word quantity, or I actually like to think of it differently. It's an amount, right? So that gets us a 2. So you're switching from Q and Q to something different, but it's an amount of stuff. It's a measurement. It's a count. It's a number, right? How old are you? It's a number. How much does this letter weigh? That's a number of kilograms or number of ounces. What temperature is it outside? Now, if I said hot or cold, that's qualitative, right? If I said 74 degrees, that's quantitative. Okay, so it's a number. When I put a number to it, it's a measurement of something. That's going to be our quantitative. Statistics deals with both in this class. Primarily, we will be working with quantitative methods for quantitative data with numbers. That's where the math part comes in. But there's also a whole field of qualitative data where you have to look at each word and you analyze in those sense. But if you go into a graduate program, a lot of times you'll take a qualitative data and they analyze it. They have special needs or special means of analyzing that type of data. This is not in your notes. This comes from the other course that I'm doing at Orosi, but so we may see this later in this course, and that's because that sometimes happens. The textbook will cover everything, but they do it in different orders. But I thought it would fit well here. When we talk about quantitative data, amounts, there are two types. One is discrete, which means it's only specific values, like your age. You're 34, you're 35. I guess you could be 34 and a half or something, but specific values, right? We count how many people are in this room. We're going to get a particular specific value, and you don't get decimals, okay? Now, decimals can be part of discrete data, say like shoe size. I can go get a 10 and a half shoe. I can get a 10 and a half, or 11, but I can't get a 10.25 shoe or 10.75. So it's still discrete, even though there's decimals involved. Does that make sense? Discrete is there's only these particular values. So generally you can count. If there's discrete, what would be the other kind of data? Non-discrete. You guys got that same as the other one. So yeah, we could say it's non-discrete. They have another word that they use, continuous, right? Continuous is it can take on any value. And that typically happens when we're measuring something like this desk. How long is it? And I can get a number, but I could take a microscope and maybe even get more accurate, get some more decimals in there. So that's a continuous process, things that we're going to like using measures and stuff. One way I like to think of this is how many are into music? All right. I used to play the violin, no frets, right? I play the mandolin, which is a similar instrument, but there's frets on it. So what I'd like to say is that if I've got, and this is a guitar neck, if I have frets, I can only put my finger in a particular place and I play this note or that note. That's discrete. If my guitar didn't have frets, like this, I can put my finger anywhere along there. I can slide it and I get all sorts of different notes, right? That's continuous music. Continuous is usually harder to deal with, right? You got to get it just in the right place to make the note sound good. With a fret, you just, as long as you've got it tuned, you put it there and you're going to have that note, okay? So discrete versus continuous. Make sense? Okay. So two types of data. Now we're going to get, and we're almost done here. I think we're in good shape. We're going to look at the 4 types of measurement, okay? Oh, wait. Back up one step. We're going to the side. So we've got a table of data here. Which part of this table has qualitative data? The what? The sports names, right? They're not numbers, right? So the easy way to spot it, and they're just, yeah. So here's our qualitative. And usually it's enough to just put qual. A little easier to see. That's the qualities. And then the other side is what? It's amounts or quantities. Quant. So you focus on that last letter, the T, the quantities, they're numbers, okay? We could add 2 of the numbers together and see total head injuries or something. We could subtract them also. And so there's a lot of things, there's math we could do with the number side, with the quantities, but with the quality side, you can't do math with it. There's no particular order to them. You could put it in alphabetical order if you wanted to and say that's an order, but other than that, it's not. Okay? Difference between qualitative and quantitative. We good with that? Okay. Now, levels of measurement. So the first level is we look at something called nominal. Maybe nominal stands for name. I think it's Latin, but something with a name. So this is strictly qualitative data. If we have qualitative data, then it's at the nominal level. So it's qualitative, basically names, labels, or qualities, but we cannot do any mathematical calculations with that data. Okay. Nominal level. If we're at the ordinal level, ordinal is similar, or can be similar, because it could be qualitative, but we could also have quantitative data that is ordinal that might fit this. One of the things that you can do with ordinal is you can put it in order. So that's maybe where the word ordinal comes from. There's an ordering. There's a first, second, third, fourth. It can be arranged in order or somehow ranked. And just like in nominal, though, that you can't really do much math with it, even if it is quantitative, that if you were to subtract the data, it's not meaningful. Okay. And we're going to see there's two other measurements where we do all the math with it. So these ones, nominal and ordinal, we don't do math with, but notice that difference. Ordinal, we can put them in order. So here's an example, two different types of data sets. Which one of these is ordinal? Which one is nominal? And why? What do you think? Ordinal, nominal. Which one has order? First one. How do you know that? Well, you see the numbers, top 5, and they give them in the order. So this one has to be, there is an ordering to it. There's a ranking. This one makes it ordinal. And so this other one over here, number 2, is there an order? No, it's just, now you could put it in the order what you like best, right? Your favorites, but that's not what's being asked. It's just a listing of genre. This may be in alphabetical order or something, but it's really just categories. So that's going to be our nominal. Okay, and actually the next slide does it for us. Ordinal, because we can put it in order. Nominal, because it's just a list of categories and there is no ordering. Cannot be ranked. So we got doing good with those two. The last two is where we really have to be careful, because those are the ones we can do the math with. And if we have one set of data and try to do a particular type of math, we might be getting something that makes absolutely no sense at all. So for the ones that are these level of measurements, we have interval and we have ratio. And they're similar, but there is a difference in them. Okay? They're both quantitative, so they're going to be numerical data, measurements, counts, and so forth. They both can be ordered. So we can put them, because they're numbers, we can put them from smallest to largest or largest to smallest, however you want to do it. The differences between the data entries is meaningful, so it means you can subtract them, and that has some value in your analysis for both of these. But here's the big difference. With interval, the 0, it's a position on a scale. So it does not mean nothing. Like if I'm measuring the temperature outside and I say it's 0 degrees, does that mean there is no temperature? No, it just means 0 is a particular temperature. It means it's cold, right? If it's in Celsius, it means water will freeze. If it's in Fahrenheit, it means it's water froze a long time ago and it's really cold. Okay, so zero. So think about it when you have your data. If zero does not mean none, that's got to be at an interval level. Okay. We'll skip down here with ratio level. One of the differences, the zero entry does imply none. I didn't get any. Nobody answered my survey, something like that. So zero means none. It's not on a scale. Difference between interval and ratio. The other thing you can do with ratio is you can take a ratio, take a fraction, divide two values, and it's meaningful, which means you get multiples. So if you take one divided by the other and get two, one is 2 times as big as the other. So that's what you can do with ratio data. As we're going to take a look at an example, interval data, we get meaningless stuff if we divide the two numbers. Okay, so the two big differences: zero. Is it part of a scale, or does it mean nothing? None, that nothing happened. And then can we divide the numbers and have something meaningful? Then it's ratio. If not, it's interval. So, and this is I should have deleted this slide. It's really the same part as the other. I just put them both on one and we go from there. So here's two pieces of data, or two tables of data. And they're both numerical. They're both quantities, right? Qualitative data. One is the New York Yankees World Series victories by year, and the other is how many home runs were hit in 2020 by various teams. Which set is interval? Which set is ratio, and why? Let's look at which one would the zero mean we had none? First one, what would the zero mean here? Remember, the data represent years, so this would be in year zero, right? Do we have things that happened before year zero? We didn't have baseball in year zero, I don't think so, but we have BC and A, right? We have, so you had, actually there is no 0 year, they do 1 year before and 1 year after, but we could have negative years or something, right? But what would 0 over here mean? It means they didn't hit any home runs, right? That means nothing. That's the one that's going to be the ratio. Over here, it's part of the scale. It's the scale of time, right? Year zero, that's what it represents. It doesn't mean nothing. It means a particular place and time. Okay. The other thing you could think about, could you take a ratio? Could you make a fraction of 1923 divided by 1927? Would that have any meaning? No. Take this year minus last year, so we could subtract them, right? 1923 minus 1927, that's 4 years, and we could say it took them 4 years. That's meaningful, but taking a ratio of the years doesn't really do anything for us. Whereas over here, we could take a ratio. We could take 77 home runs divided by, I don't know, any of these 60 home runs, and we're now comparing Seattle to Baltimore, and we'd get a decimal of 1 point something, right? And so we could see that Baltimore hit that many more home runs, that multiple of home runs, maybe 1.2 more home runs than Seattle hit, okay, whatever the math gave us. So ratios, in this case, make sense. They give us something we could use. So we could do both. So yes, so this one is our ratio, and this one is our interval. Not interval. Yeah, I got that right, didn't I? Okay. And again, we'll look at some other examples as we go on. So it is quantitative, but that's at the interval level. The years can't make a ratio. Over here, it's a ratio level. We can find the differences, and we can do ratios and get multiples. Okay, so here's just kind of a summary of all four together. So we can put all of this data can be put into categories, even numerical data. You know, you could say how many had 70 or more home runs, how many had 60. So you can make categories out of all quantitative data. Nominal, remember, cannot be put in any order. It's just categories. Everything else can be put in order. Then when we get to basically being able to do math, only the last two, you can subtract them to get differences, and only ratio can you do a ratio of. So that's kind of a good way to remember that one. That's the only one that makes sense of dividing two values. You know, who's got the biggest fish? My fish was twice as big as yours. That would make sense. That's a ratio level size of a fish. Okay. All right. And then this just gives some more examples. So this is in the PowerPoint. This is probably in your notes as well. So nominal level, just kind of summarizing. Here's an example. And all you can do with nominal is put them in the categories. They're either in the category or they're not, right? No math, no ordering. When you have ordinal level, we not only have categories, we can do that, like in the example of ratings for a movie, but it can also be put in order. And again, you do from maybe youngest age, you know, anyone can go see a G movie, but as soon as it's a PG movie, then you need your parents' permission. And if you're an NC-17, you have to be 17 or older to see those kind of movies. So we can order the rating system. So not only does a movie go into a category, but it can also be put in order. Interval level, again, this is a lot of times, it's quantitative data. So we can go with the averages. We put them in a category, we can subtract them. Now, I would question this a little, because if we've got these average temperatures, well, wait, no, this is all right. So average temperature, does 0 represent nothing on temperature? And that's okay. Interval level, 0 is part of the scale, right? So I was mixing it up a little bit. But on the ratio level, 0 would mean none. So here we've got average monthly precipitation in inches. And again, here it's a little different. You can't have negative rain. And if you had 0 rain, that means you didn't get any rain. So here the 0 is an inherent nothing. It's not part of a scale. So that's not temperatures, it's amount of rain. And then you can divide the two. And here we get, who are they talking about? By 758. So in June versus March. So June had twice as much rain as March. So we could divide the numbers and come up with multiples. Okay. When I click and there's no more slides, I know I'm done. So that's always and again, I take these right from the textbook, so we know it's all going to integrate with what's in the homework, what's in these, because that's how it's all set up. Questions? Okay, we have how much? About 5 minutes? Okay. Not sure if that's, oh, right, 12. So about 5 minutes. So what I'd like you, any questions, first of all? Okay, so if you want to, you could take out your Chromebooks. If you can get into Canvas, you can look at those notes, but to try to go through the notes that you've been doing, finish them off, finish completing them with the examples and such. And then tomorrow we will get into the My Math Lab and start looking at the homework. Okay.
Able to add students on, or who we can go to add students?
I will